Hey guys, in this week's lesson, we are just combining what we learned last week with lessons 1 through 3 and just applying them to different applications. So we're really not going to learn anything new. We're just going to learn what to do with the things that we learned last week. So I want to start off with this problem. So find the area of a regular hexagon. Well, a hexagon is a six-sided shape. And so I attempted to make one. Also, it's inscribed in a unit circle. So think back to, unit circle. Those are special because the radius, sorry, that looks hideous. The radius is 1. So I attempted to draw this. This is the best I have, guys. So I know it looks like a kindergartner did it, but we're just going to go with it. So I want to kind of talk about, let's get into some geometry. So we have this like same central angle that goes around all of these triangles here. And so I'm going to just kind of talk about the formula for that. So if you'll remember, to get that angle, you're going to take 360 divided by the number of sides, and they call that n. And so our n is 6 here. Oops. So that means that each angle is going to be 60 degrees. So we know that. Okay, now we're going to apply that area of a triangle. So notice that I have 1, 2, 3, 4, 5, 6 perfectly equal triangles. Now, in my picture, nope, they're not equal. But in a perfect world with the beautiful artist, that would be 6 perfectly equal triangles. So if we find the area of one triangle, so let's say I'm just going to focus on triangle number 1 here. Then I'm just going to multiply that by 6, and then I have the area of the whole hexagon. So let's kind of think back to what we learned last week. For the area of a triangle, you're going to take 1/2 a side times a side, and then that included angle here. So I'm going to do this side, and the included angle. Okay, so that was our formula. Oh, sorry. It's the sine of the included angle. Forgot to put the sign. Okay, so let's kind of apply this to what we have. So the side, remember, don't forget, so this is the center of this circle, this unit circle. So this is 1 and this is 1. So I have 1 times the sine of the included angle. So we found out the angle is going to be 60 degrees. Well, the sine of 60 degrees, that is square root of 3/2. So this is 1/2, and this is square root of 3/2. So the area of one triangle is square root of 3/4. So what we're going to do is we're going to multiply that by 6. So I end up getting 3 square root of 3/2. And if I type that in my calculator, I just did that a while ago, and you get about 2.6 square units. Okay, so last week we did have a problem with the parallelogram, so we're going to do another one of those problems today. And I'm going to go ahead and attempt to draw the parallelogram over here. Okay, so I attempted to draw another one. I kind of use that ink to shape, and it's okay. It's better, I guess it's better than my kindergartner one up here. But so this is what we have. So we have this parallelogram, and I wrote the lengths down here and here, and the measure of the included angle is 40 degrees. So that's how I set that up. If you'll notice, just like, I mean, this is very similar to this. This has 6 triangles. This has 2 triangles. Same concept. So if I use the area of a triangle formula and multiply it times 2, I have the area of all of this. So that's our game plan here. So I'm going to say 1/2 times 12.5 times 8 times sine of included angle. Okay, so obviously sine of 40 degrees, that's not going to be something that we can do on the unit circle. So make sure your calculator is in degree mode and then just type it in. And you should get about 32.14. And again, we're going to multiply that times 2 because we have 2 triangles. And so I get about 64 point, I'll just call it 3 square centimeters. Okay, so this is another one that a segment of a circle. So I'm going to go ahead and attempt to draw this one again. Okay, so you can see here, I drew the circle, and I went ahead and wrote the definition down. I think like the definition seems very textbooky, which it is, but I think it'll make sense like once we compare it to the picture. Okay, so region bounded by an arc of a circle. Okay, so this is the arc of the circle and the chord connecting the endpoints of the arc. So like right here. So what the segment of the circle is talking about is this shaded region right here. So between the arc and that straight line chord there. So that's what we're trying to find. Okay, so think about the definition, and we are going to, so we have this arc of the circle. So we have this area of the sector. So remember the sector, I don't want to draw over my, so remember that area of the sector, we've had that before. That's this whole area here minus the area of a triangle. So we're going to take out this triangle piece right here. So I don't know if I can draw this. So we're going to take out this piece right here. So it makes sense that we just have that little piece left over. So we know the formula for an area of a sector. So if you'll remember, that's 1/2 r squared theta. And then we've been talking about the area of a triangle, the 1/2 side, and then sine of included angle. So we can totally do this, no problem. The math isn't that hard. Just make sure that theta is in radians. Okay, so we're going to go ahead and try this problem. So we know, so we're trying to find the area, and we know that the circle has a radius of 2 feet and a central angle of 3 radians. So I'm going to make a picture real quick. I'm going to push pause, but think about 3 radians. This is what's jumping out at me when I just like look at this problem. So I know that 180 degrees is 3.14 radians. So this is really close to like a straight line. So it might do something like that. So when I'm drawing it, that's what I'm going to do. I draw this angle right here, and then I just drew right there that chord. And so remember, it's between the circle and the chord that all the area in here bounded. That's what we're trying to find. Okay, so first of all, let's go up here. So the area of the sector is 1/2 r squared theta, and then minus the area of a triangle. So notice that this is going to feel very, very similar because my radius and my side lengths are the same here. Okay, and then so sine of included angle. So this is why it has to be in radians, because it gives you theta in radians. Okay, so let's go ahead and type this in your calculator. So I got, let's see, 6 here. And 2 times, oh shoot. I did not put my calculator in radians. Make sure you do that, guys. And so I ended up getting about 5.7 square feet. Okay, so this one, the tricky part about this one is it gives us the radius and it gives us the length of the chord, but it does not give us theta. So we have to figure out theta. So I'm going to go ahead and draw a picture again. Okay, so I kind of drew out what we have. So we're still trying to find, like, I shaded in that blue part. So we're still trying to find that, but we've been given this information. So the chord length right there, that's that line that I made with that triangle. Okay, so we have to find theta. We have a side situation. So think back to last week. We either had like law of sines or law of cosines, and this setup, we had to use law of cosines. And so there was all those formulas. So it doesn't matter which one. I told you last week, like, don't get caught up into using a certain formula. We're just going to have, like, you're going to add these two sides and then like subtract this side. So like that's how we're going to use that formula. So let's go ahead and get going. So cosine inverse, and then 12 squared plus 12 squared minus, and I always think about it as like that side length opposite the angle that you're trying to find. That's the one that you're going to subtract. And then 2 times those two side lengths that are not part of that. Okay, so we're going to type that in. Okay, and I ended up getting about 0.111, like repeating. So we're going to take the cosine inverse of that. And I end up getting, when I do that, about 1.46. And guys, I'm keeping my my calculator in radians. So let's go back there. So this is going to be in radians. Okay, so I know that theta now is about 1.46 radians. Okay, so now I think I have everything I have. So I'm just going to do the area of a sector. I'll do it in color. So 1/2 r squared theta, which is that. Okay, and then I'm going to subtract the area. I was going to do this in a different color. The area of a triangle. So 1/2 side length, and then sine of included angle. And then put this whole thing in your calculator. And you should get, I did this ahead of time, you should get about 36.2 square centimeters if you typed it in your calculator correctly. Okay, so now what I want you to do is your assignments is going to be in different parts. So I want you to do part 1. So you have everything you need. I don't know why I did that. You have everything you need to do the first part of the assignment.